video, we are going to talk about generating time series from U.S. Census Bureau variables. First, we will go through the challenges into generating U.S. Census time series. Next, we will see how to discover the census variable codes that will be useful for your analysis. After that, we will use a data pipeline that we built so you can generate your own time series. And finally, we will cover how to access readily available data sets. So how do I query census variables for a single year and geographic level, and why is it then challenging to produce time series? Querying census variables is simple in essence. The Census API, alongside a myriad of packages in R and Python, allow us to query census variables once we specify the year, the survey and dataset names, and the geographic level of interest. For instance, if we wanted to query the total population and total female population for all counties in 2019, we would specify an API endpoint that looks like the one below, using year equal to 2019, survey equal to ACS, dataset equal to ACS5, and geography equal to county. We would then incorporate the variable codes here, and the Census API web service would retrieve the requested data. So couldn't I just loop the same endpoint, modifying the year to obtain time series? A problem of looping through years is that eventually we would encounter an error response code because not all census variables are available for all years and geographic levels. Another issue is that there are variable code changes from year to year, which could lead not only to response errors but possibly to a constructed time series. Last, it is worth mentioning that the number of census variables can be quite daunting, and therefore it is virtually impossible to visually go through each of the variables in a census catalog. In the rest of the video, we offer the resources and tools to simplify these challenges for you. The first resource that we will use is the CAFÉ US Census tutorial, which is found on GitHub. You will find the same link in the description below. Clicking on it takes us to the root folder of the repository. The homepage of the repository, we find the README, which presents a brief tutorial organized as 10 frequently asked questions, focusing specifically on two census surveys, the American Community Survey and the Decennial Census. For this presentation, we will jump directly to some key considerations. As we mentioned previously, time and geographic coverage can vary. So for ACS1, keep in mind that there is no ZICTA coverage, that the data is available only for regions with a population of 65,000 or more, that Hispanic data was incorporated from 2009 onwards, and that because of COVID, there are no 2020 ACS one-year estimates. We also mentioned before that there are variable code changes. So the document provides a link to the official list of changes for both the ACS1 and a little below the links to the yearly ACS5 table changes. Now, let's review how we can check the geographic coverage of a census dataset. Similar to the queries we described in the beginning of the video, we can replace the year, survey, and dataset name in a URL entry point, and we will get a list of geographies. For example, if we follow this URL, we retrieve an HTML table, and we can validate that zip code tabulation area level data is available for the 2017 ACS5 estimate. Similarly, in the tutorial, we find how to retrieve the list of variables for a given census dataset. Using the same logic of the URL entry point, we obtain an HTML table like this one. As we can see, this is a long list. So, in the second part of the video, we will talk about discovering census variable codes. To that end, if we go to the last question of the FAQs, we find a link to a Python notebook that describes how to use the CensusDis or Census Discover package. Open the notebook in Binder to show that it can be rendered online. Binder automatically identified that it had to install the Census disk package as well as all the others that are used. And now we are ready to import the Census DIS data module to explore the hierarchical organization of the census data. We will begin with the All Datasets function, which retrieves a list of all datasets that are available. As we can see, there are more than 1,600 datasets. If we filter those whose title contains American Community Survey 5-year, we get 5 datasets, like the ACS5 Details, ACS5 Profile, or the ACS5 PUMS. While not all census has the same structure, in general, you will find that the hierarchy is as follows. In essence, a survey like ACS is made up of datasets like ACS5, which are made up of groups or tables that in turn are made up of variables. The census disk package offers the all groups function, which returns the list of groups that belong to a given dataset. For example, in this line, we are pulling the 2010 ACS5 groups, and we can see that it is made up of 939 rows. Notice that the output shows the corresponding code for each group. Once we have identified a code of interest, we can use the all variables function to return a list of variables belonging to such group. The output will include the codes for each variable. So let's dissect the components of the ACS variable codes. As you might have noticed, the first component corresponds to the group code or table ID, which is followed by a sequence number indicating the position of a given variable within a table. The code ends with a modifier, which can be E for estimate or M for margin of error. Another useful function that the census disk package offers is the group tree function, as it allows to view the tree structure of variables within a group. In the notebook, we find 2 examples of trees. As we can see, the groups can vary significantly in depth and number of leaves. While hierarchy groups are useful for gaining a better understanding of census variables, it is still hard to fully grasp the wide offering of sociodemographics that are available. This is why, in this notebook, we offer an illustration on how to use NLP to obtain word embeddings and create clusters of variables. In the example, we use the k-means model on all ACS5 profile variables. We set k equal to 15 and obtain clusters like the following. A cluster related with race variables, another one related with health characteristics and assets, and a different one made up of educational attainment and school enrollment. We will not go through the 15 clusters, but we will use a cluster visualization to view the semantic distance between variables. For example, we see that this cluster has to do with income, which is closer to variables that have to do with rent, and is farther away from this cluster of variables that are related with marital status, or others related to family characteristics, which are all residing on this side. Notice, though, that in this example, we used a Wikipedia corpus and single word embeddings, and that using instead BioBERT or SciBERT sentence embeddings would provide better insights of the types of variables and the distance between them.
Now that we've gone through all the concepts, we will use a ready-to-use open source data pipeline for extracting census time series, which you can access through GitHub.
I'm using online VS Code to show that you do not need to install any software on your machine to run this pipeline. The CodeSpaces instance that I'm running has 4 cores consisting of gigabytes of RAM. In the README, you will find the instructions to run the data pipeline. For the video, we will use the SnickMake workflow. I already created the Kana environment with the Python package dependencies and entered this environment variables. So we can go ahead and activate the environment and run the next command. Once we run it, we see that these data paths were generated. And now we are ready to run the SnickMake command. SnickMake orchestrates the steps that need to be run. In this case, we see that the pipeline is made up of 19 download steps and one merging step. Currently, it is fetching all the years for variable housing units. As explained above, this pipeline is governed by a configuration YAML as the one found here. In the file, we find a compiled list of codes that correspond to a given concept like population, median age, and others. You can include additional codes into this YAML file to create your own variables. Currently, SnakeMake has finished running one of the 21 steps, so it has completed 5%. Once the pipeline is done, you will find the output file stored in the output folder.
Fortunately, you don't need to run the pipeline yourself, as you can find a readily available census time series dataset in Dataverse. Use the DOI link that is shown to download the data.